The boundary between the digital and the biological is no longer a line. It is a hybrid fabric. We have spent 70 years building computers out of silent, cold silicon. But in 2026, the most advanced intelligence isn't just silicon. It's wet. We are entering the era of the silicon biology interface. The landmark paper The Silicon Cell has shifted the paradigm. We are moving beyond simple sensors that watch life toward Bio-CMOS hybrid systems where silicon and biology perform joint computation. Imagine a standard CMOS chip, but instead of just transistors, it is integrated with ion-sensitive field effect transistors, or ISFETs. These chips can monitor DNA reaction chemistries and cellular metabolism in real time. At the single-cell level, we are effectively filming the chemical language of life at 90 frames per second. But the real breakthrough is in what we call Wet-Neuromorphic Computing. While the tech industry builds GPUs to mimic the brain, synthetic biologists are using the brain's own substrate. Researchers are now using engineered E. coli and mammalian cells to perform logic operations and gates, Oregon gates, and decoders within microfluidic chambers. These biological neural networks act as reservoirs for AI tasks, where the silicon interface handles the high-speed input and output, while the living cells perform the complex, nonlinear processing. This isn't science fiction. It is functional biocompatibility. Northwestern University has already demonstrated flexible, printed artificial neurons made of graphene that generate electrical spikes identical to biological ones. These neurons have successfully triggered responses in living brain tissue, marking the first time we can talk to the nervous system in its own electrical tongue. We are also seeing the rise of high-density microelectrode arrays with over 26,000 electrodes on a single die. This allows us to interface with brain organoids, three-dimensional clusters of living brain cells, mapping their neural activity with unprecedented resolution. We are building digital twins of biological processes, creating silicon cells that allow us to predict and program life before it is even synthesized. The contrarian reality of the next decade is that AGI will not be a software program running in a cloud data center. It will be a hybrid entity, a digital brain that breathes, a silicon chip that heals, and an intelligence that is as much a part of the biosphere as it is the technosphere. The age of the machine is ending. The age of the hybrid has begun. Stay informed, stay critical, and prepare for a future where intelligence finally has a pulse.